Hi, my name is Andy Barnes, and today I'm going to be showing you the parametric modeling capabilities inside of SOLIDWORKS 3D CAD. We're going to be taking a look at this Homaltro rescue spreader, more commonly known as the Jaws of Life. When Homaltro started making this, they were actually doing it on AutoCAD 2D, and they were doing just regular Windows folders. And they noticed they were having a ton of problems with a bunch of stuff as far as file management, making sure they're on the latest rev, testing, and they were able to actually cut down a ton on that by being able to have SOLIDWORKS as a singular solution where they're running product data management and doing their simulation inside of SOLIDWORKS as well so that they could test it ahead of time. First thing we're going to do is actually create a 3D part, and then from that 3D part we'll create a traditional 2D drawing with a bunch of different types of views, and then we'll use that to create a 3D assembly. After that we'll create a 2D drawing of the assembly complete with balloons and bill of materials. So let's get started by creating a 3D part. We're going to start off with this rod end. So I'm going to hop over into SOLIDWORKS. You can actually see my 3D model in here. I'm able to rotate it around easily, and I can even hide components. And the relationships between these components are still maintained. Now you can see that we're getting pretty close with this assembly, but we actually need to create another part that's going to connect this piston with this arm. So I'll start by creating a new part. Select my template, and then I'll just get sketching. The great thing about SOLIDWORKS is I'm able to just create what we call a napkin sketch, where I can just create the general shape very quickly and easily using intuitive commands. And as I sketch out that shape, SOLIDWORKS is automatically adding references in the background. I'm going to actually add a couple holes there that are going to end up being my machined holes. After everything's there, what I can do is actually just start adding dimensions to it. So it's going to be 40 high here, and you'll notice that as I select different geometry, it'll actually change what type of dimension it is. So I actually don't have to think about what type of dimension I'm creating. I just add it and it knows to do it. Here I could add another dimension on the other machined hole, but since I want them both to be equal, what I can also do is just select both of them and just tell them that they're equal. And in no time at all, I have a fully defined sketch that's ready to be pulled into 3D. So I can do that with my extrude command. Just select what I want to pull, and you'll see that I can drag it either direction, but I can also say that I want to create that mid-plane. This is to preserve symmetry so that later on I'll have my origin set up as being in the middle. At this point what I want to do is add a couple rounds. I can do that with the SOLIDWORKS fillet tool, and I'll just select the edges that I want to fillet and then enter the radial value. Next thing I want to do is actually add a slot that goes across the top here. So I'll just simply create a sketch on the top and create a shape that is my slot. You'll notice I'm actually able to pick up silhouette edges as well, making it really easy to fully define what I'm trying to dimension here. And just by grabbing this sketch, you'll notice I can either pull it into open space or I can actually drag it down into the model, and it'll actually create a cut from that. So you can see the tools inside of here when I'm creating the model are very intuitive. At this point I want to create a circular boss on the bottom that's going to be the threaded rod that's going to actually thread into the piston. So once again, I'll just create the sketch geometry that I want, apply the dimension, and then pull that into 3D space. So I actually have a threaded hole that I want to go inside of the threaded rod. And for that I can actually use the hole wizard feature. The hole wizard feature is great. It's like having the entire machinist handbook right inside the side of your screen. You can see that right in here I can add a whole host of holes, counter bores, countersinks, through holes, tapped holes, and any kind of hole that I can possibly come up with. We also have the ability to do slots. For this one I'm actually going to create a tapped hole, an M14 by 1.5, And I want it to go 33.5 deep. You'll notice that comes in with everything that I needed. It comes in with shaded cosmetic threads, so I can see that there actually is a thread in the background there. And it will come into the drawing with the proper notes. So next what I need to do is actually put threads on the outside of this, and for that we can use the cosmetic thread feature. Notice it automatically grabs the diameter. And I can define a certain depth that I want the threads to go, or I can even just say, you know what, go up to next and chase the thread all the way up there. However, I do know that when this actually goes to get machined, it's going to be kind of difficult to chase those threads all the way up to that flat face for the machinist. So what I want to do is actually put an undercut in there. Now I could easily create that undercut using SOLIDWORKS features, but what I could also do, if this is something that I repeat over and over again, is I can create what we call a library feature. So if I'm constantly adding things like undercut, I can just put them right inside of my design library, and then I simply just drag and drop the feature that I want onto the corresponding face. I then get this 3D preview letting me know what reference geometry I need to add, and then I can even change the size of it if I want to. In this instance, I just want a diameter of 4. And there we go. Now we've got our undercut on there. We're ready to keep modeling. So the next thing I want to do is add some chamfers to break these edges. So I'll go ahead and select my chamfer tool. Put in the value that I want. You'll notice that it actually chases around tangent edges as well. It realizes the fact that since these edges are tangent to one another, you probably want the chamfer to continue around. This cuts way down on the number of edge selections that you need to make. I also want to create some fillets on the inside of here because I'm realizing that rather than my machinist having to do a flat end mill, I want him to be able to do a ball end mill in there and make life a little bit easier. So I'll go ahead and add another fillet feature for that. You notice how I can select actually through faces. And there we go. Now, I'm all done with this, but now I've realized that I actually need to make some changes. Turns out that I got a few dimensions wrong in the beginning when I guessed. What we can do with SOLIDWORKS is I can actually come in and start changing these dimensions, and since it's parametrically modeled, everything updates. No problem. So now the last thing that I need to do before I save out this part is actually apply a material. There's a few reasons I want to do that. One is once I apply a material, I'll have accurate mass properties, and then I can tell right down to the milligram what the weight of it is. I can also get accurate center of mass as well because of that. So another reason I want to add a material is actually so I can run simulations on it. If I go into the material database, select the material I want, you can see that I have things in here like elastic modulus, shear modulus, Poisson's ratio, all the things that yield strength, tensile strength, all the things that I may need to run a simulation on it later on. You notice when I apply that material, it actually also changes the visual properties as well, so it looks accurate to what I've applied it to. And after that, what I'm actually going to do is go ahead and save this part out. And I'm actually going to save it into my PDM vault. So we're going to call this part new rod end, and I'll actually add a description here as well and call it rod end. You notice that when I do that, I actually get this pop-up. And what that is actually a data card. This is part of SOLIDWORKS PDM. A data card that pops up actually gives me the ability to see any kind of different metadata properties that I might want to add to this. So I could apply something like a part number or a cost right now, or I could have those populated automatically by the program itself. And then all of this data actually becomes searchable after the fact. So now that this is saved, what I want to do is actually insert it into my assembly. So now we've saved out the part, it's in our vault, we're ready to go. So you can see it's actually really easy to learn and use. I create a 2D napkin sketch, I tie it down with different relations and dimensions, and then what I can do is I can extrude that into 3D space. Really simple. So now we're actually going to create a 2D drawing from our 3D part. And what I want you to pay attention to here is how the 2D drawing and the 3D part never become disconnected. They always are linked to one another. So we'll hop back into SolidWorks, and actually from my 3D part, I'm actually just going to go in here and say, make drawing from part. When I do that, I'm asked for a drawing template, which I can select. And then it's just as simple as dragging views in. So you'll notice that my view palette over here is already populated with all the necessary views. So you can see in no time at all I have a bunch of views that are all actually linked to one another. And then what I can do is I can start changing visual properties if I want. So for instance, if I wanted this to be shaded with edges, I could do that. I also want to show hidden lines so I can see this thread that's happening in here. So I'll change this view to show hidden lines. Now all the other views were created from that one, so they follow it. Now, I could absolutely put a bunch of dimensions in here, right? Just like I do in my sketch. I could say I want a dimension from here to here and drop in a dimension. But we've actually dimensioned a whole bunch of stuff already in our 3D part. So we're actually going to leverage those dimensions that we already made and bring them into our model. And I'm actually noticing that I have a bunch of detail over in this section in a small space. This is a great example for why I might want to use a detail view. So I'm actually going to do that. I'll come over here, I'll create a detail view, I just define where I want it to be, drag it, drop it, we're already done. I can also say I want to bring certain dimensions over to different views. I can also bring in a hole call out. Which fully defines exactly how that hole is supposed to be machined. If I wanted to modify this dimension to add extra stuff to it, I simply just click on the dimension, hover over here, and I can start adding whatever I want. For instance, I could say that there's 2 of these. I could even add a different type of tolerance to it. Say that has a limit tolerance. And maybe I'll add something like typical on the bottom. Now once I've done that, I can actually, rather than recreating that, I can actually come over here and say, you know what, I want to apply the exact same stuff that I just did to the last one to this one. Cool? And of course, I can also supplement this with my own dimensions as well. Now, the last thing I think I need is maybe a section view right here. You see how easy that is. And now all I want to do is finish this drawing up by going ahead and saving it out. I'll throw the drawing in there as well. Call it rod end drawing for description. You'll notice that I also do get a data card for this. This data card is specific to SOLIDWORKS drawings because you may have different information on here, such as checked by, approved by, all that good stuff. And you'll notice that something like material might not necessarily be on the drawing template in case it's for an assembly drawing or something. So at this point, you know, I've gotten completely done with it, and then of course what happens? We find out that somebody's decided we need to make a change. So I can come back in here. I've been told that this needs to be changed to 50. So I'll just go in here. I'll actually change that dimension at the drawing level, hit rebuild, every single view updates, and then I can actually go back into the SOLIDWORKS part file. The part file is exactly the same, right? Because the drawing is just a picture frame around my part model, which means that my 3D model is never out of sync with my 2D drawing, ensuring that I always have the latest rev, I always have the most up-to-date model. In the part file, I'll go ahead and make just one dimensional change, and I'll hop back into the drawing file, and you'll notice that every single view is changed here as well. Just go ahead and hit save again, and now we'll move on. So you can see that because the drawing and the part file are always in sync with one another, we can avoid any kind of drawing errors that may happen that then cause costly mistakes down the road. So now what we're going to do is we're going to take that 3D part and put it into our 3D assembly so that we can validate, fit, and function virtually before any metal gets cut. So I'll hop back into SOLIDWORKS, and we'll go ahead and close the drawing out for now. And I'm just going to drag and drop my part into my assembly. Just going to tell some faces that they should be lined up. And now I have my part inserted, but you can see that I'm actually still missing a link between my rod end and my arm over here. So I know that I've created this part before. I know that a link exists. I'm not sure what the name of it is. I'm not sure what the project name is, the project number, the part number. But I do know that I have a link part that I've used for a previous design, and I want to reuse that rather than creating a new link. So what I can do, since I'm actually working inside of a PDM system, is I can actually run a search. Now this is running on the backbone of SQL, so I actually have the ability to utilize the SQL database system rather than just slow Windows index searching. So I'll just search the entire vault for anything with the description of link, and you can see in just a millisecond we get 2 results right away. Now, right inside of Windows Explorer, if I click on that, not only do I get a preview, but if I click on the preview, I actually get a 3D rotatable model. So I can identify right away the fact that, is this the right part or is it not? In fact, I can even go further. Since this is utilizing e-drawings right inside of Windows Explorer, as I rotate it around, I can also utilize things like the measure tool. So I can come in here and verify that this indeed has a diameter of 22 millimeters and it is the right link that I want to use. We can also search with a whole bunch of other things. Remember before we were talking about data cards? You can search any kind of variable that sits inside of that data card, any kind of metadata that's attached to it, as opposed to just Windows index searching where pretty much your only parameters are the last person it was saved by, the file name, and the date that it was saved. And obviously it's very slow, especially if it's on a network drive. So what I'll do now is I'll actually use my search box here to just drag and drop in the parts that I want, and I'll go ahead and tell it that these 2 holes need to line up with one another. And then I'll also drag in the other part, the link pin that I was looking at before. And you'll notice that I'm also able to do things in SOLIDWORKS like select a bunch of different configurations. So maybe I have, a bunch of different sizes of the exact same part. So I can just identify which configuration of that same part that I want, and then I don't have to have a whole bunch of link pins in there. I can just have one link pin with a whole bunch of different sizes. Now we're almost ready to go here, but I still need a retaining ring that lives on the bottom. Now, you've already seen in SOLIDWORKS, it's very quick and easy to model stuff up, but if I have the sort of component that I'm going to use over and over and over again, I probably want to have that saved out separately as hardware. And in SOLIDWORKS, you actually have the ability to use what we call a toolbox. A toolbox is going to have all of the different standards from all over the world, and pretty much every nut, bolt, washer, retaining ring, O-ring that you can possibly think of is already in here. And if it's not, you can actually add stuff to the toolbox as well. So I'm going to go in here and say I want to go into anti-metric retaining rings, and I'll just drag and drop this on there, and you can see that as I start to drag and drop it, it'll actually auto size depending on which face I hover over. So I'll drop it in there. It picks the right size automatically, and there we go. So now I also want the same set of the link, the retaining ring, all of the mates that hold it together over in this other hole. Rather than having to recreate that stuff, what I can actually do is just select it and then say I want to copy with mates. And I'll just tell it, here's this mate, here's this mate, and now I'm done. Notice the link is actually too long over here, not a problem. I'll just change the configuration on it once again, and now it's the right size. Cool. We're looking pretty good, we're getting the right motion out of it. But now what we actually want to do is take all these components and put them over on the other side. Rather than having to recreate that, once again, I'll just utilize the geometry that I already have and mirror it. All I have to do is define the plane that I'll mirror it over, and we're ready to go. No time at all. I've got my fully functioning arms here. So I'll just go ahead and add all my components back in. So the next thing I might want to do is validate that everything actually fits together. So to do that, I have a few different tools. For one, I can actually come in here and I can run interference detection. I can calculate it for the entire model, see whether or not I have any parts that are occupying the same mass at the same time. After running interference detection, I can tell that there actually aren't any interferences, so we're actually pretty good to go here. But there's also another sense. I want to make sure that as I run through the full motion of this piston, that I don't have any collisions with any of the moving parts. So for that, I can actually use collision detection. So I can do it between all the components, and I'm going to tell it to stop as it collides and highlight the faces that collide. You can see when I do this, it actually stops. A sound is made if you want it to be, and you can actually see where these faces are banging into each other. So I can see that actually this angular slot that I have here inside the arm isn't big enough. So I don't even have to open up the part or go anywhere else. I can actually just activate the dimension that I want to change the dimension, and everything updates, both sides and the part file and the drawing of that part file. Everything's updated all at once, and now I can run it through its motion, and clearly there's no collision anymore. So now that we've validated function, we're ready to start creating some of the other stuff that we need. And one of the things that I'm going to need for my drawing, for my balloons, my bill of materials, for everybody to be able to see that very easily, I want to have an exploded view. In SOLIDWORKS, creating an exploded view is very easy. I've actually already started one, but obviously the components that I have just added are not yet part of the exploded view. So I'm just going to go ahead and edit the existing exploded view that I have. And really all I have to do is just select the components that I want to explode and then drag them in the direction that I want to explode them. It really is just that simple. I can also do things like I can say I want to auto space these components on drag. And what that means is as I drag them, they'll individually space from one another. And then I can even go back and space one of them individually after the fact as well. So it's really quick and easy to create a nice looking exploded view inside of SolidWorks. Once I've created that exploded view, I can easily just say right click, animate collapse, and now I have an animation of exactly the explode that I've created. And I can even save that out as an AVI file, maybe to put on a website or something. Okay, so great. So because we were able to put everything together inside of our 3D modeling package virtually, we were able to figure out that we had inappropriate dimensions that were going to cause it to not be able to run through its full motion ahead of time. And I was able to do this virtually and change stuff instantaneously before I cut any metal, before I waste any time on it. So now we're going to take a look at the 2D assembly drawing, right? I'm going to have balloons, bill of materials, an alternate position view, and I want you to focus on how quickly I can actually create this. So we'll go ahead and hop into SolidWorks, and just like before, I'm going to say I want to create a drawing from my assembly. This time I'll use my assembly drawing template. And I'll add in an exploded view. I can add in views directly from my view palette, and one of them already is isometric exploded. But as with any 2D view inside of SolidWorks, it's actually a 2D view of a 3D model. So I can actually come in here at any point and say I want to use a 3D drawing view, and I can actually rotate that around to look exactly like what I want it to. So I'm not even just tied to the standard views that we would normally create inside of other CAD programs. I can create any kind of drawing view that I want. So once I have that view, I can go in and add my bill of materials. You can see everything comes in automatically. I don't have to spend a bunch of time creating a big table. It's all already in there because of all the metadata that I've been creating as it goes. I can then go ahead and add my balloons, and with that I'll just use auto balloon. And you see my balloons instantaneously come up. They're all attached, they're all parametric. I can move them around on these great magnet lines that we have to make it look just so. I won't spend too much time on that. You get it. It's super easy to do. And this one, I want to add a top view over here. Now when I do that, what I can actually do is I can create what we call as an alternate position view. So I can actually show it in the same view with the jaws open and with the jaws closed. Now I can go to an existing configuration that I've already created called open jaws, but I could also have it bump me back into SolidWorks to create a new position using something like collision detection or just free drag. You can see now that I have that there, I can easily throw on a dimension that's going to define how wide it is when the jaws are open. And there you have it. There's our 2D drawing, complete with bill of materials, balloons, and alternate position view, all done in just a few minutes, saving you tons of time. And since this is all parametric, we can go back and make changes at any time, and we're good to go. In fact, I've been working in PDM the entire time. And once again, I'll just add a description, assembly drawing. I'll get my data card that comes up again. At this point, I could, add information like I'll say it's been checked by Jeremy and approved by Ian. Just an example of the way that I could add stuff in here. And as we talked about earlier, the fact that I can go change anything on any part of any model and it will update on the drawing is true indeed. In fact, we've actually been using PDM this entire time, right? So PDM has been a part of this the entire time. We're saving stuff into the vault, we're using the data cards, stuff like that. But actually, I can look at PDM right within SolidWorks. So I can get good information about all this stuff right within the task pane in the sidebar inside SolidWorks. So I can see all of this stuff, what state it's in. In fact, I can see that this handle that we have right here is actually is highlighted in red. And that is because we're actually working with version 1 of the handle. Because while we've been doing all this work, somebody else has been doing work on the handle assembly. So you see some other stuff in here, like I have my new rod end, the arm. I've been editing that stuff, so it hasn't been checked in yet. But what I can do is I can just right click and say Git. And when I do that, I can actually see that there's a comment that Jeremy has made on version 2 of this model. He says, the handrail is too difficult to manufacture and has been updated for a more cost-effective design. Please verify for function. So I'll go ahead and bring that in. No time at all, it swaps out the old handle design for the new handle design. I don't have to do any more work on it that's already been done. And if I go ahead and hop back inside of my drawing here, you can see that it's already updated to the new model inside of my drawing file. The balloon is still attached. The bill of materials still references the same part. We're good to go. So you can see, because all of this stuff is happening automatically, I don't need to manage it. When I make changes, I don't need to go back in and have everything be checked a bunch of times because I already know it's right because it's parametric. So there was one note on there. When Jeremy had changed the handle design, he actually said, please verify. So what I want to do is I actually want to run a simulation on this. With the new handle design, we want to make sure that it's going to hold up to stress. I mean, we're going to have, you know, firefighters, EMT workers, police officers who are under duress trying to save lives, you know, really putting this to its limits. We want to make sure that that handle is going to hold up. When they put all their force into it, it's not going to break. Right? This is literally a life and death machine. So we'll hop back into SolidWorks here and we'll open up simulation. So I'm just going to open up that handle and I'll just add in simulation. You can see it's not a separate program that I need to export to and then have it under a different interface. It's already integrated right inside of SolidWorks. I click on the button and all of a sudden I can use my simulation tools. It's that simple. I want to create a new study. This one's just going to be a static study, but you can see we have a whole bunch of different types of studies we can do. Thermal, frequency, buckling, drop test, or we can even do non-linear stuff. But for this one, we just want a regular old static study. And you can see that it actually brings over my material properties from my part, but I could actually switch those out if I wanted to. So if I wanted to run a simulation on 5 different materials with the same part, I could do that really easily as well. Connections are in case I want to run a simulation on an assembly, which I absolutely can. It's just, we're just doing the one part here, so I really don't need to. Fixtures are basically anywhere where it's tied down, right? So what I'm going to do is I'm going to say that these 4 holes are all fixed. I'm going to say it's a perfect scenario. They're bolted down perfectly. They can't possibly move. And then all I need to do is add an external load. So I'm going to add 500 newtons in a specific direction. There we go. The last step is to just mesh and run it. And when I run the study, it will actually mesh it automatically. So when I do that, I can see that the yield strength is 470, and I actually get a maximum stress of 314. So that seems like my factor of safety is actually going to be below 2, and we want a factor of safety above 2. In fact, I can even add in a factor of safety plot. I'll just make my max 10, and you can see all the places where it's below. And I'll make everything that's above that color, all right? And then what I could do is maybe I can make my max factor of safety 2, and I can see that I actually have some space down in here that is indeed below the factor of safety at 2. So it seems like all of the area that's below the factor of safety at 2 actually resides in the thickness of this plate on the bottom. So what I want to do is I'm just going to thicken up those plates just a little bit and then rerun the study. So I'm going to change that 6 to an 8. You can see that it's telling me, hey, your mesh is out of date, right? Because I've actually changed some geometry. So it gives you that visual feedback. I'll run it again. And we can see now that inside of my factor of safety plot, my minimum factor of safety is now 2.62. So we're within the boundaries that we need to be in. And once again, if you haven't figured this out by now, if I hop back into my drawing, you can see that this file has indeed updated. If I just click on that edge, I can see that it is indeed 8 millimeters. So because we can understand how to make the design better, once again, before we cut any metal, before we do any expensive testing, we can cut way down on the number of physical tests that we need to do. This isn't necessarily meant to replace physical testing. In scenarios where there's high stakes, you definitely want to run a physical test, but physical tests can be really expensive. So rather than doing 10 iterations of a physical test, or even more common, intentionally making things bulkier because you know that they won't fail, you can then waste a bunch of money on material, right? So we're able to get really close right inside the software virtually before we cut any metal, and because of that we're able to make lighter parts cheaper, faster. So as we've been walking through this, we've been using PDM the entire time. There's actually a whole bunch of other stuff that you can do with PDM. With PDM, I don't have to just manage CAD data. It's pretty great because it understands all of the complex relations that deal with CAD data, and it also understands complex CAD relations between different CAD packages as well. It's not just SolidWorks. But I can put all of my files in there. Excel files, PowerPoints, pictures, videos, PDFs, anything I want. And I can actually have automatic tasks fire off to do things like, if I have a product package that I need to create, I can have PDM automatically, once I go through an approval process, fire off, once a drawing has been created and been approved, it's going to create a PDF, it's going to create a step file, it's going to put it in a specific folder with an Excel document that defines the material properties. It can do all of that automatically. If you have highly trained engineers that are paid well, that are spending a ton of time doing that stuff, clerical work essentially, you can have PDM do it all automatically for you. That way your engineers are able to do what they're supposed to be doing and what they're paid to do, which is focusing on the design of the part. So just to run you through, we were able to create a 3D part. It was really easy. We were able to create a 2D drawing from that 3D part and able to avoid any drawing errors because the part and the drawing link up together. We then were able to take our 3D part and put it inside a 3D assembly and validate fit and function virtually. After that, we could take that assembly model with exploded view, put it into a 2D drawing, and very quickly and easily create a parametric bomb and balloons so that we understand exactly how it works. After that, we were able to run a simulation on the handle to know exactly how strong it was going to be and understand how we can make the best design possible. And we also were using PDM the entire time. So using product data management, we're able to actually search CAD data really easily, store other kind of data, work through a workflow, automatically fire off tasks, and we can replicate that on as many different sites as you want, and everybody's using their files as if they were local. So what does that mean for Homaltro? They were able to cut down on their design time by 66%. They were able to cut down on the number of prototypes they made by 33%, and they were able to cut down on the testing time by 25%. All of that spelled huge savings for them and a bunch of redundancies that were cut out. Right here in their quote, they basically said, "It used to take us 3 times as long to prepare for manufacturing, and now all of that's cut down." Well, thanks for your time, and I hope you were able to see how you might be able to use SolidWorks in your business. And if you have any questions at all, please feel free to reach out to us. You can fire off an email to trimec.com, call our support line, contact your sales rep. If you have any more questions about any of this, I'm happy to help as well. Have a great day.